Hello, everyone. Hope you're all having an amazing day. My name is Pratik Devraj, and today I'm going to be going over the Azure OpenAI service along with other models such as GPT-3, GPT-4, and of course, ChatGPT as well. I'll begin with a few slides of presentation, and then we're going to head straight into some demos in the Azure OpenAI portal. Let's start with a brief history of artificial intelligence. So AI has a long and storied history that spans many decades. Some of the earliest work in AI was done in the 50s and 60s, where researchers first began to explore the possibility of creating machines that could think like humans. And during the 50s and 60s, AI research primarily focused on symbolic AI, which involved creating symbolic representations of knowledge and using them to solve problems. Researchers in this field developed early versions of what are known as expert systems, which are computer programs that mimic the decision-making abilities of human experts in specific domains. In the 70s and 80s, AI research began to shift away from symbolic AI and towards sub-symbolic AI, which involved using statistical and mathematical models to solve problems. This shift was driven in part by the realization that symbolic AI was too complex and difficult to scale, and in part by the development of new computer hardware that made it possible to process large amount of data quickly, such as higher performance CPUs and GPUs. And in the 2000s, AI research continued to evolve and new subfields began to emerge. And one of the subfields was machine learning, which focuses on creating algorithms that allow computers to learn from data without being explicitly programmed to do so. This means you won't have if else statements to handle different scenarios. Rather, you have data that the model trains on and can make predictions based on the data that it has seen using weights. Recently, generative models such as GPT-3, ChatGPT, Dall-E, various different type of autoencoders, and generative adversarial networks, and many more have risen and continue to advance the field of AI. And the primary goal of these generative models is to take some input, usually natural language type input, specifically for GPT-3 or even Dall-E, and generate either images or even other extensions, like a text output based on a text input. AI has been growing at an incredibly fast rate. Just to give you an example, the Azure OpenAI service was made public preview in late 2022, and in early March, ChatGPT was released on Azure OpenAI. And a few weeks later, mid March, GPT-4 was also released as a preview. So every day, OpenAI models and AI in general have been making grabbing headlines. Partnership between OpenAI and Microsoft has been going on for numerous years now. It's nothing new. The early conversations had started as early as 2016, and in 2019, Microsoft made a significant contribution to OpenAI, invested in OpenAI, and the two companies, their goal is to bring AI and make AI accessible to more people by developing new AI technologies, building an AI computing platform, advancing AI research, making AI accessible, applying responsible AI and incorporating it into the models, and of course, applying the open AI and GPT technology to various different products such as Cortana, Power Virtual Agents, and the Office 365 stack as well. Within the OpenAI stack of models, there are four major categories. So the first one is the text-based models, which are GPT 3.5 and GPT 4. And then you have the ChatGPT, which can be powered by either GPT 3.5 or GPT 4, and it's tuned for more of a natural conversation. And we have the Codex models, which are basically used for generating code across different languages such as Python, SQL, C Sharp, whatever your favorite language is, based on natural language queries into code. And Dall-E 1 and 2 models, which are basically ingesting text or user queries and generating images from those text inputs. And one major differentiator between GPT 3.5 and 4 is GPT-4 is multimodal. It can work with both text inputs and image inputs as well. Similarly, Dall-E is also a multimodal model, which ingests text but generates images as output rather than text like GPT 3.5. There are several ways to consume the OpenAI, Azure OpenAI APIs. And the main way you would interact with the API is to provide a text prompt, and then the prompt would generate a response. For example, on the left here, the prompt is to write a tagline for an ice cream shop. And the response is, we serve up smiles with every scoop. And in this case, the response was not explicitly programmed. The model has learned several examples on open source data, and based on that, it can probabilistically generate outputs that match your input. Another example might be you asking it for some help on troubleshooting how to turn on your computer or Xbox, and it will generate response providing you with some pointers and like list of troubleshooting steps you can try to resolve your issue. Can also ask for recommendations on movies to watch or games to play for certain age groups, and it will definitely respond with a list of items that you can watch or try or play. And you can also use the prompt for generating natural language queries using the Codex family of models or the DaVinci based GPT 3.5 or 4.0 models as well. So it takes the natural language query and generates, in this case, a SQL output. And beside that is a natural language prompt to images, which can be called through the Dall-E 2 API. So you provide a natural language query, a ball of fire with vibrant colors to show the speed of innovation at our media and entertainment company, and it generates response based on some of the keywords that you provide into the prompt. So within the Azure OpenAI service, there are a family of models within GPT-3, and the four are Ada, Babbage, Curie, and DaVinci. And DaVinci is the most capable model, usually capable of taking on the most complex tasks. Also, it has the highest inference time and cost per token consumed as well. And DaVinci is great for applications requiring a lot of understanding of the content, like summarization for a specific type of audience. For example, you can ask it to summarize for, say, 20 like teenagers or adults, and it can understand that context. It's also great at creative content generation, for example, writing a poem. And DaVinci is also going to produce the best results overall compared to the other models when compared head on. And ultimately, these increased capabilities also require more compute resource. So yeah, as I mentioned before, DaVinci will cost more per API call, and it may not be as fast in terms of inference retrieval. Another area where DaVinci shines is understanding the intent of text. DaVinci is quite good at solving many kinds of logic problems and explaining the motives of certain characters in your queries. DaVinci has been able to solve some of the most challenging AI problems that involve cause and effect. So overall, DaVinci is great at complex intent, cause and effect, and summarization for audience. Curie is extremely powerful yet very fast. It's somewhere in between, say Babbage, Ada, and DaVinci. While DaVinci is stronger when it comes to analyzing complex text, Curie is quite capable for many nuanced tasks like sentiment classification and summarization. Curie is also good at answering questions and performing Q&A as a general service chatbot. Babbage, on the other hand, can perform straightforward tasks like simple classification, and it's also quite capable when it comes to semantic search ranking of how well document match up with search queries. And Ada finally is the fastest model and can perform tasks like parsing text, address correction, and certain kinds of classification tasks that don't require too much nuance. Ada's performance can often be improved by providing more context. Ultimately, Ada is great at parsing text, simple classification, address correction, keyword generation. And any of the tasks performed by Ada, Babbage, or Curie can also be performed by DaVinci, and oftentimes it can provide more complex answers and reason cause and effect and perform more complex type of classification and summarization for target audience. And on the right, we have the Codex family of models. And within that, we have the DaVinci and Cushman. Cushman is great at SQL queries, generating SQL queries, whereas DaVinci Codex is great at generating code for almost every other popular language. Each of the models in the GPT-3 family have different token limits. The DaVinci family model have a limit of 4,000 tokens, and Curie, Babbage, and Ada have a token limit of about 2,000. What this means is both the input and output combined can be a maximum of 4,000 in the case of DaVinci. For example, if your input prompt consists of 1,000 tokens, then the output generated by the API would be a maximum of 3,000 tokens. And just to give you a better understanding of what a token is, it can be a single word or parts of a word. For example, the word hamburger consists of 9 characters and 3 tokens. So that's hamburger, 3 tokens. Whereas the word book consists of a single token and consists of obviously 4 characters. So what we're seeing here is the OpenAI's tokenizer website. And here you can enter text and really get an understanding of how many tokens you might have in a certain paragraph just to understand tokenization better. As I was explaining earlier, the word hamburger has 3 tokens, whereas a word, let's say house, would have a single token but 5 characters. The word text has 4 characters but a single token. And the general rule of thumb is that 1 token on average corresponds to about 4 characters. So this would mean that in the case of DaVinci, where the limit is 4,000, that would mean approximately 3,000 words. And you can also, obviously copy paste whatever input if you want to get a better understanding of tokenization. So I just copy pasted that paragraph there, and I can find out how many tokens are in that paragraph prompt. And let's take a look at the pricing as well. And all the links will be provided in the description. So for the text ADA language model, the price is 0.0004 dollars, US dollars per 1,000 tokens, or per approximately 750 words. And the price varies depending on the type of model that you're working with. For example, Curie would be 0.002 or approximately 1/5 of a cent, and that per 1,000 tokens. And that's the same price for ChatGPT as well, which is also approximately 0.002 per 1,000 tokens. And we have GPT-4, and there are 2 models there, which is the 8K version and the 32K token version. So this means there's an 8K limit for the 8K model and then the 32K token limit for the 32K model. And it's slightly different when it comes to GPT-4. The prompt or whatever you enter into the the chatbot, or in this case, the actual text input, there's a slightly different pricing plan here. The prompts themselves are about half the price as the completions, or in this case, completions would be the output generated. And that's about 3 cents for the 8K version and 6 cents for the 32K version. And completions are twice as more expensive per 1,000 tokens again. We also have the language, or rather the image models, which is Dall-E, and that's set at a standard $2 per 100 images. And you can also fine tune some of these models with your own data. And in that case, the prices are listed accordingly. And the fine tuning is essentially the data that you would provide for fine tuning, and that also applies the same per 1,000 token standard. And in order to train, there's also an hourly cost as well. Depending on the type of model that you choose, there is a flat rate of training compute per hour. And hosting the model, once you've fine-tuned it, also has a price as well. For instance, hosting an ADA text ADA model would be 5 cents per hour for the fine-tuned models. So I've mentioned a couple of concepts such as prompts, inputs, and completions. So let's take a look at some of these very quickly. When it comes to prompt design, there are three main components. So for example, in this text here, we're asking the API to extract the mailing address from this email. And everything in green is the input for the API. And in the blue is the context. So we're providing instructions for the API on what to do. So in this case, the instructions are to extract the mailing address from the email. And ultimately, based on this email and the context, which is in blue, the output is in red, which is the completion, which is the output that the GPT-3 or GPT-4 models generate. So let's take a look at the Azure AI stack. And Stack is essentially a set of services offered by Microsoft as part of its Azure cloud platform. The Azure AI services are designed to make it easier for developers and organizations to add AI capabilities into their application without the need for extensive expertise in AI. And some of these services include cognitive services, which are found in this box here. And these are a collection of pre-built APIs that allow developers to add capabilities such as natural language understanding, computer vision, and speech recognition to their applications. And below that is the Azure Machine Learning Service, which is a cloud-based platform that allows developers to build, deploy, manage machine learning models end to end, and also build their own custom models, deploy them, and apply MLOps frameworks to automatically retrain and deploy models. So that's like your custom model building platform. And the scenario-based applied AI services enable organizations to accelerate adoption by using services such as cognitive search, which provides search capabilities over structured and unstructured data. And there are other tools as well, such as form recognizer and video indexer, which can essentially give you an analytics from video clips, and it can even detect celebrities and even perform transcription and translation, whereas form recognizer can help break down unstructured data. It can detect tables, it can detect some sort of key value based pairs in documents. For example, a PDF that you might have scanned, it can extract all the contents from that particular PDF. So these are scenario based services. The scenario-based services, cognitive services, and the Azure Machine Learning Service are targeted toward developers and data scientists, whereas the Microsoft 365 stack and the AI builder solutions such as Power BI, Power Apps, Power App Automate also benefit from OpenAI and Azure AI services, where these capabilities are infused into almost all the service offerings. For example, with PowerPoint, you have the designer, which can suggest different design ideas based on a few examples of slides you may provide. And in Power BI is powered by the GPT family of Codex models, which can help generate natural language queries. And ultimately, almost all the services will have AI infused in them in one manner or another. I want to quickly touch base on the Microsoft Responsible AI as well. And their journey began way back in 2017. And the development of AI is guided by the creation of an ethical AI framework. And in 2018, there were 6 core principles that guide work around AI. And these principles are privacy and security, inclusiveness, accountability, transparency, fairness, reliability, and safety. And these 6 principles ultimately guide development of some of the OpenAI models on Azure OpenAI service. And in order to get these principles in action, it's not always straightforward. The key processes that you would have to have in place is governance, and then rules to standardize the AI requirements. Then you would have the training and best practices to actually understand and start leveraging these principles. And ultimately, you would need the tools and processes for implementation into your models. And the good news is OpenAI service already has many of these components enabled within them out of the box, such as content moderation and ethical use moderation as well. I wanted to make an important note on the usage of data. So any of the data that you use through the API with the Azure OpenAI service, or the data that you use for fine-tuning model, will be stored encrypted at rest within your organization's subscription. So the data is always under your control, and the data is not going to be used to train any of the OpenAI models that are going to be available within Azure OpenAI service. The only models that will use your data will be the ones that you train within your environments. So basically, the ones that you're going to be fine tuning will reside in your subscription and only be accessible by your organization that you, or like folks within your organization that you allow access through role-based access control. And the applications with OpenAI models are limitless, from use cases ranging from summarizing text to acting as virtual power agents or assistants using ChatGPT, to language translation, classification, code commenting, code refactoring, image generation. There's a variety of different use cases. And why don't we take a look at some of these examples by going through the Azure AI portal and trying out the models ourselves. So currently, in order to gain access to Azure OpenAI service, you would have to complete this form. And this is subject to change at any given time. But at the time of recording in March of 2023, this are the current instructions. In order to get that approved within your Azure subscription, you'd have to fill out this form. Pretty straightforward. You'd provide your name, your subscription information, your subscription IDs, and use your company email address and a few other small bits of information. And yeah, it's pretty straightforward, really, the type of company that you're working for and regions that you're requesting access for. So currently, there are 3 regions, 3 data centers that support OpenAI, just South Central US, West Europe, and East US. And you can request for both the text code models, so the Codex and DaVinci Codex, and DaVinci Text, and Dall-E models as well, which is the text-to-image model. And fairly straightforward form. And once you have submitted this request, you would also submit a request to the OpenAI GPT-4 preview as well. So once you have submitted the form, submit this form as well. And that puts you in a wait list currently for GPT-4. Once you do have access, you'll be able to spin up that OpenAI resource through the Azure portal. And ultimately, you'll land at this web page, which is called the Azure OpenAI Studio, which can be accessed by going to oai.azure.com. And here it's called the Playground. And you have access to both ChatGPT and all the GPT-3 models, including the deployments and any kind of custom models that you want to build. And deploying a model, one of the different 4 families of models, is very straightforward. You would begin by selecting the type of base model that you want to work with. For example, let's say I want to test out the text similarity or text query model. And I personally like to use the same name for the deployment, but you can have any name that you wish. And I'm just going to call it text DaVinci-001. And it's as simple as that. And that will deploy the model. It may take a minute or two, but that model is deployed, and we can use that model for testing within the playground. So on the left blade here, we have the GPT-3 playground, and we can test out all the models that we've deployed. So right now I have deployed 5 models, the GPT 3.5 Turbo, which is powering ChatGPT, and 4 other text models that I can use. Let's start with the text DaVinci-002 model, and let's take a look at some of the examples or demos that are available here. There's a plethora of different use cases, but here are some demo ones that are provided here. So one example might be parsing an unstructured data from a paragraph. And in this case, they're talking about fruits that are found on this planet called Kukrux, and there's different type of fruits there. And our goal is to create a table summarizing the fruits from this planet. And we're providing some examples on how we want to structure the output, right? We want the output in fruit, color, and flavor format. And you provide some examples of how that would look like. So Neo Skizzles, purple and sweet, and in that manner. So 1 or 2 examples of how we want to extract that information. And this is the way we would parse the unstructured data. So let's click generate, and we get the output from this paragraph. So it's gone through pole units, for example, is another fruit, the bright green color, and it's more savory than sweet. So that was extracted, and the other 2 fruits were also extracted as well. And this is one example of using prompt engineering to extract or parse unstructured data. And this type of example is called a few-shot learning. And there's different type of ways to prompt engineer, and these major concepts are called zero-shot, one-shot, and few-shot learning. And in this case, because we provided different examples of how we want the output to look like, this would be considered a few-shot learning type example of prompt engineering. And a couple more concepts. On the right blade here, we have a few parameters. One of the parameters is the temperature slider. And essentially what this controls is randomness. Lowering the temperature means that the model will produce more repetitive and deterministic responses, whereas increasing the temperature will result in more unexpected or creative responses. So if you want to say generate something creative like writing a poem, maybe you want to set the temperature to a higher value because you want creativity. Whereas if you just want something extracting unstructured data, you want just the keywords or the text, expected text, so you'll get more deterministic responses every time. And max token length is essentially the max number of output, right? Just to reiterate, for Text DaVinci, there's a max token output of 4,000 for both the input and output. And in this case, we've set it to 100 tokens. So the max completion or the output generated by the DaVinci model will not exceed 100 tokens in this case. Take a look at another example here. So we're asking the model to translate the following two sentences to French and Spanish. And this is also a zero-shot example. We're not providing any examples of how we want the translation to happen. And upon clicking enter, we get back the translations of the sentences. Let's take a look at another example here. So let's just try Text DaVinci again. And let's ask it to generate a quiz. And we're asking to generate a multiple choice quiz from the paragraph below. We want to have at least 5 questions, and each answer should be on a separate line with the blank line separating each question. And we also provide a single shot example as well. And let's see what the response looks like. So there we go. Based on the first example, it's generating 3 or 4 more questions based on this text input. And you can also have other type of examples as well, such as classifying text. So in this case, we're trying to classify each of these headlines into a different category, such as business, tech, politics, sports, or entertainment. And we're providing one example, like one shot example here to provide how the output would look like. And in this case, the major retailer announces plans to close over 100 stores, and this particular headline is related to business. So in this example, I'm going to be using the Text DaVinci 3 model, which is the latest of the GPT-3 models. And the example here is going to be the chain of thought reasoning. So there's a word problem here, and we provided one example where the question is, Quansodo made a sale for $50, the raw material cost $10, the labor was $20, and what was the profit on sale? And then we want the answer in this format, right? And the question here is, Fabricom sold 100 widgets for $10 each. However, 30 of the widgets were returned for a full refund. How much money did Fabricom make? So let's click enter and see what the response looks like. So that sounds about right. The answer is $700. So in this case, the model is performing chain of thought reasoning and understanding the context of your question and also doing basic arithmetic operations as well. Now let's take a look at how different models perform for a simple classification task, such as classifying a certain headline that I showed earlier. And in this case, naturally, Text DaVinci 3 will get that category correct. And now let's see how the other models perform. Ada, being the least capable, the earliest model, is also going to get it correctly because it was designed for simple classification tasks. So a lot of times you don't need the most powerful model for simple tasks. You can use text Ada for basic classification types. And likely, similarly, Curie will also get that correct. So all the models were able to classify correctly in this example. Now let's take a look at ChatGPT. So far, we were looking at the Text DaVinci, Curie, and Ada models, but now let's take a look at the ChatGPT, which is powered by GPT-3 Turbo model, which is an implementation of the Text DaVinci models. And here it's probably very similar to the responses you're going to get based on the OpenAI version of ChatGPT. So we can ask for what's the fastest animal, and it's going to respond very similar to the open source model that most folks have used. So it tells you the fastest animal in this case is the cheetah, and we can ask follow-up questions by saying what's the fastest animal on say water. And what's happening here is the model is actually recognizing the statefulness of the conversation. So it remembers state and context, and that context is passed on into the next prompt. So in this case, it recognizes that I'm talking about cheetahs, which is a land animal, and then it goes to dolphins when asked about the fastest animal on water. And we can also ask it the fastest uh, overall, fastest overall. And my intent here was to ask what's the fastest animal, regardless of land, air, or water. In this case, it responds accordingly, saying that the peregrine falcon is the fastest animal with speeds of up to 240 miles per hour. You can also request the model to generate some sort of creative content. For example, here I can ask the model to write a poem for a friend of mine. Write a poem for Anna. Let's provide some context about the things that she likes. Likes read books, outgoing, and adventurous. And let's take a look at the output. So that was quite the creative poem that the model was able to generate. You can also adjust the parameters by increasing the temperature for a bit more creativity, a bit more randomness, and we can also increase the max response length as well. If you want a longer poem, and I can ask for a longer version, and it will try to comply with your request based on the new changes to the max response token count and also the increased temperature count as well. So there you go. That's the response that was generated from the model based on the new parameters. You can also customize the bot's behavior by providing some instructions that the bot can follow. The default instruction is that you are an AI assistant that helps people find information. This prompt can be anything that you'd like. For example, there are some pre-built ones. In this case, this one is a JSON format assistant, so we can change that to provide instructions for the bot. So in this case, the assistant is an AI chatbot that helps users turn a natural language list into a JSON format. So let's try that. Let's clear the chat here and let's type in some natural language query that contains a list of items. I have the following items in my shopping cart: milk, eggs, bread. And let's see what the response looks like. Okay, so I have the items and the name of all the items in that shopping cart converted to JSON format. So you can use this to create natural language to JSON output. And it's not limited to just JSON. You can also change this to other language as well. So let's try changing this into a natural language to Python code converter. Turns a natural language query into Python code. Okay, so that's going to be my new set of instruction. Okay, so let's ask the bot, write a script to import or write a script to push data into a blob storage. I had a spelling mistake there, but it's still able to recognize the context. And it's providing me with some Python example using the Python SDK to write some data into a blob storage. There are plenty of other ways to provide instructions for your chatbot, and there are other examples here such as customer support agent, marketing writing assistant, hiking recommendation chatbots. But really, the possibilities are limitless. You can really set up any type of instruction that you want and that makes sense for your particular use case. And there's many other ways to prompt engineer as well, which I will likely go over in a separate video. I did want to quickly touch base on the Dall-E model, which, as I was mentioning earlier in the presentation, is a natural language to image generation type model. It's a multimodal model, and let's just have the model generate some example of what I'm looking for. So in this case, the natural language query that was automatically generated would be a cat, submarine camera, digital art, and the cat is also playing with the dog. So I'm just modifying the recommended query with additional information, and let's generate an image based on this particular set of query. So it does take a bit of time to generate that image. And there we go. Based on our instructions, we got some creative images. That's pretty interesting. And it can be anything, right? Let's try another example. So an astronaut lounging in a tropical resort in space, vaporware. Okay, let's try that. And the key here is to provide as much detail as possible. The more detail that you provide, the better the quality of your image. Okay, so there you go. It's output of the model. And you get a few output, like 4 examples that you can choose from. So that brings us to the conclusion of this presentation. Thank you all for watching. And I hope that you found all of these examples useful. I'll also be providing the links to all the documents that I was referencing in the description. And for the next video, I'll be talking about how we can leverage our own data and have the model reference our own data using additional Azure services. So for now, thank you so much and hope to catch you next time. Take care, everyone. Bye.